Hey guys, welcome back to another video. So this is our fourth assignment on linear regression. This will be the last assignment on this topic. So in this video we will be doing subset selection. So let's get straight into question 1 that says load the German credit data with 21 variables and exclude the variable default status. So we will use read.csv function to read our file and then store the data frame in a variable called German_credit. Now to exclude the default status variable, we have used subset function and have put the column number with a minus sign, which means we want to exclude this column. Now let's move to part A of question 1. It is asking us to perform best subset selection regression using amount as the dependent variable and other variables as predictors using the German credit dataset. So we will use REG subset function, which is a model selection approach that consists of testing all possible combination of the predictor variables and then selecting the best model according to some statistical criteria. It also has a tuning parameter NVMax, which can be used to define maximum number of predictors that is to be incorporated in the model. But we will not be using it as of now. So let's see how do we use REG subsets function. Now first we will load the library which has this function. So we will load Leaps library as shown here. Now we don't have to install any package for this library because this is already an inbuilt library. So we will directly load this library using the library function. Now we will use REG subset function. It is to be used just like the LM function. We regress the response variable, that is amount, on rest of the variables. And then give the second argument, that is our data frame. So REG subset function will perform regression and will also select the best variables. Now we will run this function and store our model in a variable called regfit. We will also store the summary of our model using the summary function and store it in a variable sum. After that we can print summary and see the results. So as you can see, our results are printed here. Now let's see the explanation given below to understand the result. Now as you can see here, we have two columns against forced in and forced out. So here you can see in the summary, these are the two columns. Now these arguments, if turned true, are used to explicitly include or exclude a particular variable. Also, as we move down, you can see asterisk marked against the included variables. By default, it gives a model of up to 8 variables. However, we can use NVMax function to modify the number of variables that are required in the model. So this is what in a nutshell the output of REG subset function tells us. Now moving to the next part, it says plot the statistic R square and adjusted R square. So we will use plot function to plot the R square and adjusted R square. Here the first argument would be the adjusted R square. We can simply subset it from sum where we have stored our summary by using a $sign. And then we can name x-axis as variables and y-axis as R square. After that, type B means we need points and line plots. And then color and thickness is mentioned, and then we have closed the bracket. After that, we will add R square using the points function. If you recall, we use point function along with the plot function to add another variable on the same plot. So we will use point function to add R square on the same plot. So first argument for the point function is R square. We can subset it from the variable sum where we have stored our summary by using a $sign as shown here. And then again we have used type is equal to B. and then thickness is given by PCH, and color is given by COL function. After that, we will run this and we'll get our graph as shown here. Now we can notice from the graph that both R square and adjusted R square are increasing. Hence, we need further investigation and cannot conclude anything from here. So let's understand more about it from the explanation given here. So first point, we have already discussed that both the metrics are increasing, so we cannot conclude anything from it and we need further investigation. The second point says R square is a basic matrix which tells us how much variance has been explained by the model. Now what happens in a multivariate linear regression is that if you keep on adding new variables, the R square value will always increase, irrespective of the variable significance. So what adjusted R square do? It calculates R square from only those variables which are significant. So always while doing a multivariate linear regression, we should look at the adjusted R square instead of R square. So right now, as we can see from the graph, both the metrics are increasing, so we cannot conclude anything from it, and we will do further investigation. Now moving to the next question, it says find the coefficient of the best model. So for this question, we can simply use COEF function and mention the number of coefficients that are required. In our case, the number is 8 because by default, RG subset function gives the model with 8 variables. So we will use COEF function, mention our model which is stored in RG fit, and then mention the number of variables which is 8. We will run this and store it in a variable COEFI. Then we can print the result and we can see below the intercept and the coefficients are printed. So these are the best coefficients out of 21 variables according to RG subset function in default settings. Now moving to the next question, which says use validation approach to build the model. So if you recall, we had seen different approaches for variable selection. First approach was validation approach, in which we build models starting from one variable and it goes up to including all the variables. So in this question, it is asking us to do the same. So let's see how it is done in R. So first we will set the seed. Now we set the seed so that we can generate the same random numbers every time. Otherwise, if we don't set the seed, each time we will run this code, we will get a new series of random numbers. So for example, if we run the sample function to create the sample, it will create a sample, let's say using 1, 2, 3, 4, 5 observation. And then if we run it for the second time, it may create a sample with observation number as 5, 6, 7, 8, 9, and so on. That is the reason we set the seed. So every time it will generate the same random numbers. Now I have used set.seed within brackets 10. So you can use any number. There is no specific reason why I am using 10. After setting the seed, we will first split the data into training and test part. So we will again use the sample function. This time we are using a different approach for splitting the data. As I said earlier, there are different approaches to create samples. So in different assignments, I am showing you different approaches so that you can learn variety of approaches. Here we will create a sample of true and false equal to the number of rows of the German credit dataset. So the first argument here is the vector true and false. Then the second argument is the sample size, which is the number of rows of the German credit dataset. And then repeat is equal to true. This way we will get 1000 entries of true and false randomly generated. And after that we will use this to generate German underscore test, which will have the test data that will have 1000 entries opposite to the German underscore train variable. For example, if German underscore train has entries like true, true, false, true, etc., then German test will have entries like false, false, true, false. Now German underscore train and German underscore test are generic variables, and now we can use it to subset our data. So let's directly create our model using the RAG subset function using the training data. So we will regress amount onto other variables like so. Then in the data, we will mention German underscore credit, and within square bracket, we will mention the generic variable German underscore train that we had created earlier. And then a comma sign, which means it will subset all the rows, and then we'll close the square bracket. So this way we are directly creating the training data set in the RAG subset function itself. After that, we will run this and we will store our model in a variable called ragfit underscore val. After this, we will create a design matrix using model.matrix function. Now, what is a design matrix? Design matrix is used to store the data of predictor variable, and one column is created for the intercept. Now, if we multiply the coefficients of our model that we have created to this design matrix, we will get our response variable. So this is the whole idea of design matrix. We will see in the below loop how do we do it. So first we will use model.matrix function and create a design matrix and store it in the variable called test underscore met. Now the arguments of design matrix are similar to regression. The only difference here is instead of the training data, we are using the test data here. After that, we can create a null matrix with 8 rows using the matrix function and store it in a variable val.error, which is basically validation error. And then we will initiate the for loop, which will go from 1 to 8 for all the variables. See, ideally validation approach should have used all the 20 variables, as we have 20 variables in the original data set. But just for demonstration purposes, I am using 8 variables. That is the reason our loop is also going from 1 to 8. Now let's see what is happening in the loop. So we will first calculate the coefficient and store it in a variable COEFI2, which is basically coefficient 2. So guys, I am giving these names so that I can remember all these things later on. You can give any other name of your choice as well. So here we have used the function COEF to find the coefficients from our training model, which is stored in ragfit underscore val. After that, we have used id is equal to I as the second argument. Because in the validation approach, we start with one variable model and then go up to including all the variables. So id value will start from 1 and it will go up to 8. So it will store the coefficient of the best model as per the value of I. So if the I value is equal to 2, so it will store the coefficient of the best model with 2 variables. And if the I value is 3, then it will store the coefficients of the best model with 3 variables and so on. Then we will multiply the design matrix with this coefficient to calculate our response variable and store it in a variable called PRET, which is basically prediction. So basically what will happen here, let's say for one variable model, we will have one intercept term and one coefficient. So it will multiply the intercept term with the intercept column in the design matrix, and intercept column in our design matrix has a value of 1. So whatever the intercept term is there in our model will be stored in it as it is. And then the coefficient will be multiplied by its variable. And then both the terms will be added and we will get the predicted value of y. So that is how design matrix is used to calculate the predicted value of y. Now you may ask, how come it is the predicted value? Because if you have noticed, so when we created the design matrix using the model.matrix function, we use our test data instead of the training data. That is the reason when we calculate y, it will be the predicted value. And then we'll calculate the validation error and store it in a variable val.error which we have created earlier. Now how do we calculate the validation error? We use MSE, which is mean squared error. We have our test data where our amount is already there, and then we have our predicted variable where we have calculated the amount. So we will just use them to calculate MSE. In the first argument, we are subsetting the amount variable based on the test data, which is stored in German underscore test. So we can simply write German underscore credit, and then we will use $sign to subset amount variable, and then we will use square bracket to subset the test data. This way we will get amount variable from the test data. And then we have stored the predicted values of the amount in the PRED variable. So we will simply subtract it. Then we will square it and then take the mean. So basically what is happening here, we had our original data, which is the German credit data. Then we created a split of training and test data. Then on the training data, we built our model. And then based on the predictor stored in the test data, we made our prediction and found out the amount variable, which is the response variable. Now in the test data, we already have the amount variable. So we are just subtracting the predicted value of the amount variable from the amount variable that is available in test data. Because that is the whole purpose of creating the training and test split. Because we have built our model on the training data and now we want to check how good our prediction is. So we are making the prediction using the predictor of the test data and then checking the response available in the test data with our prediction. So I hope this has made it clear. Now similarly in the next iteration of the loop, when I will be 2, two coefficients will be extracted using the COEF function. Then these two coefficients will be multiplied by the two variables and the intercept term will be added to calculate y. And then again we will calculate the validation error, and then this loop will continue for all the 8 variables. After this we will print our results, which are stored in vali.error. So here you can see the validation error for model with 1 variable, 2 variable and up to 8 variables. So if you see, the validation errors keep on decreasing as we keep on adding the variables. Now we can use COEF function to select the model with the least validation error. So we will write COEF, open the bracket, write our first argument as regfit underscore val, which is our model, and then we will use which.min function. Now which.min function will return the number of variables corresponding to least validation error. And then COEF function will return the coefficients of that model. Now I have just used which.min function to make it a general code. I could have simply mentioned 8 because from the previous results we can see that the model with 8 variables has a minimum validation error. However, as I mentioned earlier, I don't like to hard code. You could have just mentioned the number manually, but I prefer making the code generic in nature. Anyways, it was a bit complicated code because we are doing for the first time, but I have included a complete explanation below. Although I have already explained it in detail, still if you have any confusion, you can go through it. So that was the validation approach in a nutshell. Now moving on to the next question, it is asking us to run the model on the entire data set. So we can use COEF function again. This time we will use regfit model that we had created in the beginning. So let's go back and see which was this model. Now as you can see here, this model was built on the entire data set. So we will use this model to find the best variables. Now the second argument would be the minimum number of variables corresponding to minimum validation error. So we will again use which.min function and we will run this, and the coefficient of our best fit model are calculated here. Now since we have given minimum validation error as the criteria, which is stored in the variable vali.error, so but natural, we will get a model with 8 variables. Now we have seen one approach for variable selection. In the next approach, we will do forward and backward selections. So let's move on to the next question, question 2. Now question 2 says, perform forward selection stepwise regression using amount as dependent variable and other variables as predictors. So we will again use reg subset function, and we will use it in the same way as we did earlier. But this time we will include the method as forward because we are doing forward selection. We will run this and store it in a variable called regfit underscore fwd. So fwd is basically forward. After that, we will check the summary using the summary function and store it in a variable called sum underscore fwd. And then we can review the summary if required, but I have already explained the summary, so I am skipping it now. Next, we will print the coefficients using the cof function, but this time we will view the coefficients corresponding to maximum r square. So we will mention cof function, then open the bracket, then mention our model as our first argument, which is stored in regfit underscore forward. Then instead of which.min, we will use which.max because we want the model with maximum r square. And then we know that we can get r square from the summary function. So we will use summary function, give our model as the argument, and then use the $sign to subset the r square. We will run this, and here you can see we have got our results printed. Now again, it has given 8 variables because by default it gives 8 variables. However, if we want to tweak it, we can use nvmax function as discussed earlier. Now we'll move to the next question, which says perform backward selection. So the procedure for performing the backward selection will remain the same, except that the method will be changed to backward. Now you can see I have also added one more argument, which is really.big is equal to true. This argument is basically used for an exhaustive search when the dataset is really big. Say when the dataset has more than 50 variables. Now in our case, the variables are only 20, but I have just included it for demonstration purposes so that you learn a new argument. After that, we will run this and we will store the model in a variable called regfit underscore bwd, which is basically backward. Now again, we can store the summary as well, as shown here. And again, I'm skipping the summary because I have already explained the summary. After that, we will use the cof function to calculate the best coefficients using r square, like we did for the forward selection. We will run this and we will get our results printed here. Now in the end, we will just summarize the result from all 3 methods and see what all variables have been selected by these methods. So first we will just print the coefficients from these methods. So for the validation approach, coefficients are stored in the variable called coefi. So we will just print it. And for forward selection, we will write this formula again and we'll get our result printed. And then for backward selection, we'll again write the formula and we'll get our results printed. Now you can see from the results, all the methods have selected the same 8 coefficients. Hence, we can be pretty sure that these are the most important variables. So that is how you do the subset selection. So that was all guys from subset selection. Let's quickly see what we have covered so far. So first we have seen the validation approach, then we did forward selection, and then we did backward selection. We also have learned to use model.matrix function in a loop while working on validation approach. So model.matrix function creates a design matrix that we had used to calculate our response variable. Now with this, we have completed our first topic, linear regression. So I really hope guys you have benefited from this and I have expanded your understanding of the topic. I also hope you have learned some new programming skills as well. Now in the upcoming section, we will be doing a lot more and there's some really interesting stuff which is lined up now. Alright then, I'll see you again in the next video. Until then, keep learning. See you.